Hello. Let's say we want to calculate something using a dilution. When you're diluting something, typically what you're doing is you're changing the solvent amount. So we're going to make an assumption. We're going to assume that the moles of solute remains constant. So if I want to say a question like here, an experiment in a general chemistry laboratory calls for a 2 molar solution of hydrochloric acid. How many milliliters of 11.9 molar hydrochloric acid would be required to make 250 milliliters of 2 molar hydrochloric acid? This might be a common thing that you would do, I would do, if I were making a solution for a lab. We typically would buy a bottle of hydrochloric acid that is pretty concentrated, about 12 molar, and I would want to add more solvent to it. Typically, I'm doing with an aqueous solution, so this might be adding water to it, to dilute it down to the concentration I need. Recall that the formula for molarity is moles over liters. If we make the assumption that the moles of the solute remains constant, then any one set of values would equal a second set of values. So for dilution, I'm going to have an equation where the concentration initially times the initial volume will still get the same answer as the final concentration and the final volume, because when they multiply out, they give the same number of moles of solute. So let's go ahead and try to answer this question. Again, with any word problem, you want to start by writing out what you know and don't know. So I want to figure out my initial concentration, my final concentration, my initial and final volumes. If I look here, I'm going to start with a bottle of 11.9 molar hydrochloric acid solution, because that's my initial concentration. I don't know how many milliliters I'm going to need. That's what I want to solve for, so that's my unknown. But I know that I want to end up having a concentration of 2 molar hydrochloric acid and make 250 milliliters of the solution. Notice that this number, 2, was repeated in the question, and we only need to use it once. Since I'm solving for the initial volume, what I'm going to do is divide by the molarity over here to give me an equation of M2V2 over M1. And at this point, I can just go ahead and plug and chug. I can see that my units here for molar hydrochloric acid will cancel out top and bottom. I can pull out a calculator, get the answer, which I get to be 42.01681. If we look back at the problem here, we have 3 sig figs, 3 sig figs, 3 sig figs. So my answer should also be 3 sig figs. That would mean that number right there, meaning that I would have to use 42 milliliters. Let's try another example. What is the final concentration of the solution produced when 225.5 milliliters of a 0.09988 molar solution of sodium carbonate is allowed to evaporate until the solution volume is reduced to 45 milliliters? So in the first question, we added solvent to reduce the concentration, to dilute it. But here we are removing solvent through evaporation. And again, it doesn't tell me that it's necessarily water, but any solvent, maybe it's alcohol. And it's going down to a smaller volume. We would expect that my answer would give me a higher concentration. So I'm looking for that at the end. If I'm starting with this concentration, I should have a greater concentration when I'm done. Regardless, we're going to assume that the moles of solute remains constant throughout, so we can go back and we can still use our dilution equation of M1 V1 equals M2 V2. Start off by writing out what we know and don't know. I am starting with a concentration of 0.0998 molar, and I'm starting with 225.5 milliliters of the solution. I'm ending up with an unknown concentration, but 45 milliliters are left. I want to solve for the second concentration here. So what I'm going to do is I'm going to divide both sides by the volume to give me an expression, M1 V1 divided by V2. And then I can just plug and chug. So plug in my values for each of the concentrations of volumes in my notes. In this case, notice that there's milliliters on the bottom and milliliters on the top. So I can cancel those out. When I solve, I get the answer 0.50050977777 repeating. That's 4 sig figs, that's 4 sig figs, that's 4 sig figs. So go ahead, 1, 2, 3, 4, look here. And I'm just going to round to the 4 sig fig as well. Meaning my answer is going to be 0.5005 molar sodium carbonate.